Hello Python students. In this lecture, we will try to summarize all the contents which we have covered so far in this course. As you can see, in first 6 weeks, we discussed about some core concepts involved in Python language. And then in last 4 weeks, we talked about some little bit advanced concepts related to Python. Now, in this lecture, we will revise all these concepts quickly by summarizing them in small modules. So let's start that. First is data types. Now, after learning object-oriented programming, we can comfortably say every entity in Python is an object, including data types. Majorly, there are 5 categories of data types: numeric, sequence, dictionary, set and boolean. Whereas numeric category is divided into 3 sub data types: integer, float and complex numbers. Similarly, sequence category is also divided into 3 sub data types: string, list and tuple. And as you can observe, in each those box which represents individual data type has 2 lines. First line represents the name of the data type or the class name of the data type, whereas the second line represents the way through which we can create that data type. As in, that second line represents the constructor of that specific class. After that, we talked about variables. As we know, in Python, we don't have to declare variables in advance. Whenever we assign a value against a variable, that variable gets initialized by default. On top of that, Python also allows dynamic typing, which means data type of a particular variable can be converted from one form to other. For example, first, if we store one integer value inside a variable, then that same variable can be later on used to store a value of different data type as well. And that's what the dynamic typing is. After that, we also talked about the rules which we have to follow while naming a variable. Variable name can be any sequence of characters from A to Z in lowercase, uppercase, numbers from 0 to 9 and one special character which is underscore. And in such a sequence, there is only one constraint which says the name of the variable cannot start with a number and variable names are case sensitive. After that, we talked about operators in Python. Majorly, there are 5 categories of operators in Python, namely arithmetic, comparison, logical, membership and identity. We use arithmetic operators in order to perform mathematical operations, whereas comparison operators are used mostly with conditional statements or loops. Logical operators are used in expressions, whereas we use membership operators along with data structures to check the membership of an element, whereas identity operators are used majorly with objects to check the identity of individual entity. After this, we talked about formatted printing, where we focused majorly on 2 different types of functions called fstring and format. Fstring allows us to modify our output using print statement in a certain way, whereas format also allows us to print output on the console in a specific manner. Using either of these methods, as a programmer, we can take more control over how an output is going to get printed on the console. In addition to that, we also use something called as escape characters, which allows us to use special characters as part of string which was not possible earlier. Like backslash, single quotes, double quotes, new line character, or even a tab. After that, we also talked about importance of libraries and different ways to import a specific library in Python. As you can see, there are 5 different ways using which you can import a library in Python. First way will import the library, whereas second method will import all the contents of that library. Third method will import a specific variable or a specific method from that library. Fourth method is similar to first method, but this time we can import a library with a specific name. And then fifth method is similar to third method. But once again, the fifth method will allow us to import a specific method or a variable using specific name. Once we learned about import statements, we also have to talk about the external libraries which we discussed in this course, which are Pandas, NumPy and Matplotlib. And then we briefly saw a few examples using these 3 libraries. As we all know, these are external libraries, hence they all have their own detailed documentation available over internet. Hence, we have added the links to those specific documentations in this particular slide. You can simply click on any of these libraries and it will take you to the detailed documentation of that specific library. Moving on, next is conditional statements. Conditional statements are nothing but those if-else blocks. We talked about if, we talked about else if, we also talked about else block. And we all know how the execution of if, else if and else works together. After that, we also talked about something called as inline if-else, or popularly known as ternary operator, which allows you to write the entire if-else code block into a single line. And if you remember, this will not improve the efficiency of the code, but it will certainly help you while writing some simple if-else blocks. Instead of writing that code in number of lines, we can instead replace it with a single line. After that, we also saw there are all sorts of nesting is possible with respect to this conditional statement. You can have if-else inside if, you can have if-else inside else if, inside else, and so on. So all sorts of different combinations of these nesting is possible with conditional statements. After conditional statements, the most useful component of any programming language is loops. In Python, we saw 2 different types of loops, while and for. In for loop, we also talked about 2 different variations of for loop. One using range function, whereas other one without using range function. And this second category of for loop is also referred as for each. Both types of for loops and while loop can be used inside each other. Hence, once again, all sorts of different nesting is possible and allowed by Python language. Loop allows us to automate repetitive steps, but sometimes due to some situation in the specific program, we may prefer to have control over the way the iterations are happening in a specific loop. And that is the place where we use these 3 loop control statements like break, continue and pass. Break allows us to terminate the loop. Continue allows us to skip an iteration, whereas pass allows us to ignore a specific condition. And as we were discussing about for loop using range function, hence this range function becomes very important with respect to Python programming language. So let's look at that range function in detail. This range function can take maximum 3 arguments. The first one is start, second is end, and third is step. Start represents the starting point for that particular range. It is an optional argument and the default value is 0. End specifies the end point for the sequence, and this end point is non-inclusive. And this particular argument is a mandatory argument. If we write a range function with only one number, as you can see over here in the first example of for loop, that number is considered as the end value. And the third argument is step. Once again, it is an integer value where we can specify with how much margin you want to increment or decrement the values in the sequence. It is an optional argument and the default value is 1. As we were talking about some inbuilt functions like range, there are many other inbuilt functions which we should learn along with it. Like print, which allows us to print some value on the console. Input allows us to accept some value as an input from console. Type is a function which allows us to check the type of a specific object. Len returns the length of an object. Max function gives us the largest value in the iterable. Mean function gives us the smallest value in the iterable. Sum function gives the sum of the elements in the iterator. Sorted function sorts the given input and returns a list. Iter returns an iterable object. Next is a function which allows us to iterate over any iterator object. Enumerate returns an enumerate object by adding counter to an iterable. Zip returns an iterator after coupling 2 or more iterators. Map returns iterator after applying specific function on each element inside that particular iterator. Filter function returns an iterator after applying specific filtering function on every value inside that iterator. But as we know, these inbuilt functions are not sufficient in most of the cases. Hence, we have to write our own functions, and those functions are referred as user-defined functions. User-defined functions can also take a number of parameters, they can return values, and so on. And as you can see here, this is how we can define a function or call a function. These functions can have 3 different types of arguments. First are purely based on the position or the sequence in which the arguments are written. Hence, they are referred as positional arguments. The second category is referred as keyword arguments. In this case, along with arguments, we also have to specify the parameter variable explicitly. Hence, in this case, the sequence or the position of any argument is not important. And then the third category is default argument. This allows us to have a default value for a specific argument. If user provides that value, then we override default value. Or if user doesn't provide a value, we continue the execution of the function with the default value. Exactly the way we saw in range function. And the only constraint is the default arguments should be assigned at the end of list of parameters. Moving to next concept, which is collections in Python, as in data structures in Python. We saw 4 different types of collections in Python: list, tuple, dictionary and set. And this particular table provides the brief overview of all these 4 collections in Python. For more details, we have added the specific video links of these 4 collections in this particular table itself. These are the same lectures which you studied earlier in week 6. In fact, this table representing the comparison between these 4 collections was also available in that particular week. So instead of spending too much time on this, let's move to next concept, which is recursive function. Now from this slide onwards, we will focus on those last 4 weeks where we discussed about some advanced concepts in Python, like recursive function. Recursive function is a type of a function which calls itself. As in, function calls itself in its own definition, and in such a case, the function is referred as recursive function. After that, we also talked about one more different type of function called Lambda function. Lambda function is an anonymous function which can take any number of arguments but can execute only one expression. And this is the example of such anonymous function. With respect to functional programming aspect, we also saw one more component called list comprehension. This allows us to create a list in more optimized manner. As you can see, here we are creating a list using iterator and a conditional statement. Even though we are doing all this, it is happening in just one line. Along with functional programming, we also talked about one very important aspect of any programming language called exception handling. We also said exception handling is considered as a standard way to write a program. And as we all know, exceptions are different from syntax errors. Errors which occur during execution of a program are termed as exceptions. And Python provides something called as try except blocks in order to handle such exceptions. You must also remember there are a very long list of such inbuilt exceptions available in Python. Hence, once again, we have provided an external link to exception handling documentation provided by Python, where you can see the list of all such exceptions at a one place. Along with try except blocks, we also discussed about one more block called finally. And this is a special code block which always executes irrespective of whether the program runs successfully or it terminates with an exception. In either cases, this finally block will always execute. Therefore, it is a good practice to deallocate the system resources used in program in finally block. For example, closing of a file pointer. Along with exception handling, we also talked about file handling. We store all our information digitally using files. Hence, there has to be some way through which we can read, write those files using Python. And that is why we studied some specific functions which are used in order to open or create a file, which is an open function. It takes 2 parameters. First is file name and second is the mode in which a file can be opened. This mode can be create, read, append, write, and the type of file can be either text or binary. like an image. Specifically for reading a file, we have three major functions called read, readLine and readLines. And for writing, we use a standard function called write. After file handling, we also talked about one different way of approaching a Python program, and that new approach is referred as object-oriented programming. This particular concept allowed us to translate our real-time objects and the relations between objects into a Python program. And that is where we introduced the concept of classes and objects. Class is created using a keyword called class, whereas object can be created using a constructor of a class. Every class can have attributes and methods. These attributes can be initialized using a special method called init. All the functions which are defined inside a class are referred as methods. Along with some default methods of every class, we can also define some user-defined methods as well, like this display method over here. And as I mentioned earlier, object-oriented programming allows us to translate not just object, relations between objects as well. And that is when we discuss something called as inheritance, where we discussed how one class can be created by taking help of another class. And in such a case, the original class is referred as parent class or a base class or a superclass, whereas this newly created class is referred as child class or derived class or subclass. We also talked about various different types of inheritance, and these types are simple, hierarchical, multiple, multi-level and hybrid. And that is all we have studied in this particular course. Now you all must be wondering what's after this, and the answer is this particular flowchart over here, which shows the transition of your study from computational thinking to programming in Python to 2 levels of diploma available in this particular program. These are only few courses which belong to that particular diploma. In order to get either of these diplomas, there are some n number of courses which you have to complete, out of which these are some courses where you will use Python programming language, or you will use some concepts which you studied in this language. For example, if we consider diploma in programming, then the subjects like programming data structures and algorithm using Python, modern application development 1 and 2 will be taught using Python. Whereas the concepts like exception handling, object-oriented programming, inheritance and so on, you will study once again during programming concept in Java course. Over there, the implementation of that concept might vary, but still the concept which you studied here will remain the same. On the other side, which is diploma in data science, once again the courses like machine learning foundations, techniques and practice will be taught using Python language. Whereas the course like tools in data science will involve lot of different tools, and out of those many tools, one very important tool will be Python language. And as you know, there are many other courses involved in these two diplomas, and even after that there is one more level which is degree level. But at this point, let's not talk about that level. Let's go one step at a time. So after computational thinking, we studied programming in Python. Now you have to start thinking about courses involved in diploma level, and especially those where you can use this Python language in order to study those courses. And with that, I conclude this lecture and this course. All the best. Thank you for watching. Happy learning.